Ni hao and xie. It's a pleasure to be in Taiwan and an honor to participate in this event. So thank you for this opportunity. My presentation today is about how to build a better UAV. Vicor has been involved with a number of UAV manufacturers for the past 2.5 decades. And we've started a long time ago with some of the early designs of these products, mostly in the aerospace and defense or Mil-Kot's world, I would say. But you know, now there's commercial UAVs everywhere. And not only aerial, but also on land and on water and underwater. So there's a lot of opportunities in this regard. So from a Vicor standpoint, our strategy is to produce high-performance power modules. And with that, it provides a building block for what we call a power delivery network. So this allows what I would refer for, I don't call them the designer, but the system architect, to easily adapt the type of power they need for their specific application. We've come across, as competitors, silver box solutions, certainly discrete designs, and what we pitch is the modular design. And here you can see some of the limitations of a silver box design in regards to heavy, you know, it's a static interface, there's no flexibility to upgrade easily, and no scalability. So that's one of the reasons why we've chosen our type of strategy. Also, in comparison, discrete solution, where you're up against design complexity, okay? Requires extensive design engineering and test, longer design and integration times, large bill of materials, difficult to scale, and lack of design flexibility. Which brings us to our strategy, the Vicor strategy. You know, we're looking at power-dense and scalable type solutions. The key for our designs are to take our topologies and build them just like a semiconductor. Like a semiconductor's on a wafer, Vicor's decided, well, we'll put our products on a wafer, on a what we call a panel. And that way, we can use different topologies and technologies. We can create different sizes. We can scale by combining different powertrains. And that way, multi-kilowatt type designs can be created easily. So you can see in this is showing the panel that we do and how easy it is once we can get the manufacturing facility set up for this, which we have. And then we can build from that these easily designed power delivery networks based on the requirements of the application. So the advantages, improve overall UAV performance. As UAVs become larger, more loads are required, there's going to be a lot of different types of requirements from the power system. So therefore, even the battery packs are different voltages, and you've got to be thinking about the ability to make it easy to implement a power solution, and then easy to scale it or change it, because a lot of times time to market is critical for a lot of these designs. So what we're looking at is to optimize size and weight, reduce system cost, and minimize complexity. One point I'll make here is that Vicor, with these power modules, focuses on challenging applications. And in saying that, we're talking about, products and technology that provide very small size and very lightweight. And that's what's attracted a lot of the UAV customers in the US to Vicor. Now, as you might imagine, beyond the UAV, there's a lot of different parts that go into the system. And here you can see some of the things that we've been involved with powering. It can be from gimbals, you name it, to transmitters, wireless controllers, antennas, A lot of things go into it. So we not only sell to the UAV manufacturers, but to some of the customers that actually make parts for the UAV. So we've broken this presentation into two sections. One is where we really got a big start in the UAV market is with tethered drones. So here you've got a cable that goes to the device. And the common requirements are it's got to be close to the host vehicle or a control base. It's got to be portable. That's what that's all about. Long operating times are typically the reason for using a tether. And it's, long operating times, hard to reach or dangerous environments, and then common use, eye-in-the-sky surveillance, construction inspections, or over line-of-sight communications. Now, we've worked with a number of vendors in understanding the challenges of a tether. And obviously, size and weight are critical here. So we're looking at, gauge of wire, as an example, and length, and what that means. So certainly from a power aspect, what we're looking at is going to higher voltages in this regard. And that's been a big push for the products that we've been bringing to market, is thinking about, okay, we need to make an efficient, power-dense, but high-voltage product. And that's something that we've come to pass and have products in that regard. So we've focused on 400 volts for a long time, but more recently, now we're getting up to 800 volts and even higher. Customers want to be able to, have long tethers with minimal drop, and obviously high voltages leads to lower current, less loss. So that's key in this application. And that's basically what I'm saying here. You can see with a 16 gauge wire, comparing 400 volts or 800 volts running up that tether, it's dramatic in regards to the, how much power you can get at a higher voltage through that wire. So again, easily to scale and add more payload. So a lot of times people will have a basic design, and then they'll have to add more capability to the UAV. So the power system has to be able to manage that kind of growth. Having a power component approach allows us this kind of capability. So we can easily parallel modules, stack them in series for higher voltages. We can change them out because a lot of times they're the same form factor and same interconnect. So that allows a lot of flexibility and ease of making design changes. And that's key to a lot of the manufacturing that goes on today. So supporting more functionality, that's the key. As I mentioned, battery packs are a lot of different voltages that are involved. Each manufacturer, there's no standardization. So each manufacturer decides a lot of times what they want for voltages. And with a battery, you've got to understand the range that it's got to operate in, and this is key. So we've focused on a lot, we've learned a lot from our interaction with defense contractors, and we worked on a lot of big systems to begin with, but this has helped us manage and understand the type of products that these customers are looking for. So high efficiency PDN, this is key. As we want the battery life to be as long as possible, a converter has to be high efficiency. It's got to be low power dissipation, and it's got to be no load power dissipation has to be very low. So when things are not working, that's not still draining the battery at a high rate of speed. So the focus for Vicor is to pick topologies with technology that gives us the highest efficiency. And that's what we're really pushing for when we bring a product to market. So here you can see a PDN with the 800 volt tether. It turns it down to a 48 volt bus internal, and then on board there's a number of different loads. We have found we can really optimize converters on a 48 volt bus, and many industries have adopted 48 volts. I mean, the telecom industry started out at 48 volts, but more recently automotive has switched to 48 volts because really it's the safest high voltage you can get. But we have technologies that are optimized for 48 volts where we can get efficiencies in the high 90s, which is amazing for a DC to DC converter. So autonomous battery-powered drone applications. Let us talk about some of the applications that we've been in. And here we can see an untethered application, typically high maneuverability, longer flight times, control interface, sensors, cameras, wireless communications, motors are the types of loads that we would be up against. Oftentimes, there's low voltage battery applications that we're involved with, 24 volts. Yes, we do have 24 volt solutions as well, but 48 is where we're pretty much focused on. But here you can see an application where inertial sensors, such as an accelerometer, was needed to be powered, navigation sensors, very typical for a UAV type of application. And then the benefits of upgrading to 48 volts. As you might imagine, converting to 48 volts can extend the range, increase load capacity, and also potentially reduce size and weight. Because again, our converters are optimized for 48 volts. That's where we're finding we're getting the highest power density. So this is key for us, and we want to keep pushing 48 volts wherever we can. So one of the applications I was involved with, and you show a video before of it, is a large manufacturer in the United States that delivers packages. And I personally worked on the power system design inside this delivery drone. And there were a number of requirements. Certainly it was a challenging application where there was not a lot of space for the power management system. So we had to think of creative ways and how to get that power system on the PC board, along and powering a flight computer, sensors, maybe a camera in one instance. So they looked at a number of different solutions that Vicor had to offer, and they found that using our DC to DC converter, the DCM, was the optimal solution for them. But there's a number of options to choose from, which is always good in regards to giving the system architect a lot of different choices. Here's the what we call the power delivery network, and we like to show these. It's a simplification of the overall architecture that's inside the UAV, but it shows the loads, it shows the bus voltages and the source, typically the battery source that is coming off. In their case, it was the 48 volts was the battery voltage that they had in the delivery drone. So that worked out really well. It was a perfect match with Vicor products. More recently, we came across an application in Korea, hydrogen fuel cell. So this is an interesting application. You know, this is Doosan Mobility, and they chose a Vicor solution, and they happen to be the leader in the hydrogen fuel cell arena in regards to providing that on a UAV. And that, that was, you could see here, about 4 to 5 times that of a battery, enabling the drones to fly up to 2 hours. So, that was delivering global humanitarian relief. It's a great thing. They were able to get medical supplies to an island off of Korea with this drone. So it was pretty good. You could see that there's some attributes here in regards to the rated power they had was 2.7 kilowatts. And system weight, 21.9 kilograms, that without, with the hydrogen tank, and then with the load, the payload could be up to 3 kilograms. So these are challenging applications. Power is needed in small size, lightweight. And the Power Pack had 2 main delivery networks, or PDNs. They supply the drone's rotors and the intelligent controller for the 2 stacks. And due to the wide range and variable output voltage of the DP30, which is the hydrogen fuel cell, it was roughly 40 to 74 volts. So that input range fit with one of our products really nicely. So we're able to provide tightly regulated output voltages at 48 volts, at 12 amps, and 12 volts at 8 amps. And this is their drawing of basically the powertrain. And it's a major advantage in regards to extended runtime and for these surveillance missions. And again, hydrogen-based drones, I think, is something that might be an up-and-coming thing, and hopefully we'll find more applications in this regard. It's better in the field. You know, I was attracted to this knowing, you know, moving liquid fuel like gas or diesel in the field is not easy. I mean, so, you know, this is a big advantage, or generators to charge batteries. I mean, so this is a big push, not only for this type of application, but for many different types of drones. So again, we're looking at this application where high efficiency and high energy density was key in delivering the right solution for this customer. And here we're saying that, you know, the digital control board uses a lower power PRM. So these are some of the products that we have, you know, in regards to easily adapting a power delivery network to the type of solution this customer needs. And from my experience, everyone wants a different architecture. It's hard to standardize in this field, but it's a very lucrative opportunity, and there's a lot of activity going on. So, long-range UAV applications. This was one of our first applications that I was involved with also. These are the high-altitude, long-endurance type of UAVs, primarily for aerospace and defense. And this is a customer in Southern California that we worked on their airframe to design the right power delivery network. There's a lot of power in this airframe, and they had a lot of different types of loads, as you can imagine. And so Vicor was the chosen product. And we started out with our legacy products, if you can believe that, in this type of application, and then upgraded to a, you know, some of our more advanced capabilities. So there's a big advantage here. And, you know, again, they kept pushing us. We need compact, lightweight, and we had a DCM that could be easily paralleled. Very simply, ease of use was an important aspect. And advanced packaging to manage the thermals. And then also you can see here 11 kilowatt solution, the size of a tablet computer, only weighing 215 grams. So a little closer at their power delivery network. The takeaway here is, yes, these were batteries inside the airframe, and they're focused on 270 volts. Why? Because that's a mil standard voltage that's characterized for surges and spikes, and also 28 volts. So they wanted conversion from 270 to 28, and that was easily done for our products. We do a lot of defense-type applications like this. These are very easy to parallel. You can see some of the capabilities of that product range and how easily it can be used in this type of an application. And looking at a little closer is how they applied it in that regard. And they leveraged, you know, in the mill world, they use the acronym SWAP, size, weight, and power. So they're always focused on that. And they have a turbine that provides our three-phase rectified voltage, and then we filter it, and then we put it through into a DC to DC converter. Now, one of the things they wanted to be able to do in this application was that in the event that they lost power with the generator, they wanted to be able to use the 28-volt battery to at least get the system back. So they wanted a bi-directional solution. So that was key. And we rose to the occasion for that regard. We had a product, because since it's regulated, we didn't have a single product that did bi-directional, but we're able to do it in a way that allowed them to get voltage from the 28-volt battery in the event of a fault. So, you know, we proposed this regulated, isolated bidirectional system. We demoed it for them. You hear some of the voltages and power levels. And from an external voltage sense and logic circuit for the automatic control of power flow direction, and then a logic configured to always back up high voltage bus and avoid a condition where both powertrains are active. So this is what we demoed for them in regards to having the bidirectional capability. Now, we're working on new controllers now, both for our regulated converters that will be bidirectional, but we also have presently what we call fixed ratio converters that are already bidirectional. And we've been getting those into different markets already. So that's kind of exciting. Bidirectional operation is a key thing that's going forward in a number of different fields, because a lot of times you want to recycle that energy, and that's important, especially with batteries. So this was a lucrative application. So looking in general, the type of applications we've been involved with, there is an e-book on our website that shows these products and their power delivery networks, but just referring to all the types of things that Vicor has been providing power for, anywhere from media and entertainment. This has been an interesting one. Unmanned aircraft off the solar cells, agricultural UAVs, which you had a video for, that was interesting. Surveillance UAVs, of course, Tethered has been a big deal for us. That's how we got our start. And delivery UAVs, inspection UAVs, the hydrogen fuel cell, and now UAVs with wireless charging. That's a new application that one of our applications engineers are working with. So these modules, again, are power dense. Flexibility and scalability is what we're really pushing with this solution. And we hope, this has been informative. We have some more information about the product specifically with our FAE that's here today. So thank you very much for your time. I appreciate it.